Today's purpose of the day is I can analyze data using measures of variation. Please read the Why section on page 756 and answer the following questions, or below is the paragraph with the following questions. Please be ready to share out. Let's take a look at some new vocabulary from 12.3 Statistics and Parameters. A statistical inference is conclusions drawn about an entire population based on the statistics of the sample. A statistic is the measure that describes a characteristic of a sample, and a parameter is a measure that describes a characteristic of a population. Let's take a look at the first example. At a local university, a random sample of 40 scholarship applicants is selected. The mean grade point average of the 40 applicants is calculated. What is the sample, population, sample statistic, and population parameter? Well, the sample here that is being selected to figure out the average grade point average, here it would be the 40 scholarship applicants. The population from which they chose the 40 scholarship applicants was all the scholarship applicants. The sample statistics, so what they're measuring from that sample, is the mean GPA or grade point average of the 40 scholarship applicants. And the population parameter, here again the parameter is a measure that describes the characteristic of an entire population. Here it would be the mean GPA of all the applicants. So as you can see, population goes with population parameter and sample statistic goes with sample. All right, let's take a look at another example. Example 2. A stratified random sample of registered nurses is selected from all hospitals in a 3-county area, and the median salary is calculated. What is the sample, population, sample statistic, and population parameter? The sample that is being chosen here are the selected registered nurses in the 3-county area. The population from which they chose the sample was all registered nurses. The sample statistic here, what is being measured from the sample, that's the median salary of the selected registered nurses in the 3-county area. And the population parameter, so what is being measured from the entire population, that's the median salary of all registered nurses. So we figured out the sample, which measures with the sample statistic, the population, which also measures with the population parameter for this example. Let's take a look at measures of variation. Measures of variation shows the spread of the data. And this can also be represented by range, quartiles, interquartile range, and so on. But we are going to use 2 specific measures of variation called variation and standard deviation. Variation, listed here, is represented by sigma squared. So this symbol here is called sigma, and then we are squaring it, so it's called sigma squared. And this is the average of the squared differences from the mean. And the mean, again, represents the average. Then we'll also look at standard deviation, and this is the square root of the variance, which is right above. And this is represented by sigma. That's that symbol right there with no squared symbol, so it's just sigma. And this shows how the data deviates from the mean, from the average. Now, with the data points given from the March Madness basketball tournament, we are going to find the mean, variance, and standard deviation. So to find the mean, we are going to write X with the bar notation, and that represents the mean. That's the symbol we will use. So to find the average, we are going to take all the data points, add them up, and then divide by the total number of data points that we have. So when I add those all up and divide by 8, I get approximately 71.75. So that's my mean or my average. Now I'm going to find the variance. So to find the variance, again, that's called sigma squared. So variance I'm going to take all the numbers listed and find the difference between that data point and the mean, square that, and add that to then the difference between the next data point and the mean, and square that, and that is what's known as the variance. So that will look like 87 minus 71.75, the quantity squared, plus 62 minus 71.75, the quantity squared, plus 61 minus 71.75, quantity squared, and I have to do this for every data point, so I'll continue to do that. And I have 8 different items here, so I do need to divide it all by 8. And so my variance here is 59.19. So again, what the variance shows is it's the average of the squared differences from the mean, so how the data spreads. So now I need to find the standard deviation. So again, I'm going to take the square root here of the variance. So sigma, or standard deviation, would equal the square root of 59.19, which equals about 7.7. And we'll talk a little bit more in class tomorrow of what the standard deviation looks like. So from the average, you could be 1 standard deviation away, 2 standard deviations away from the average, and so that means you could potentially be on the higher end and be a couple standard deviations away and be in, for example, like the 90th percentile, or you could be, a couple of standard deviations away on the other side of the mean, the average, and have a lower score and be, for example, in like the 20th percentile or 30th percentile if you're talking about test scores. So we'll look at that tomorrow, and the shape of a bell curve and how the average should typically follow a bell curve, and standard deviation and variance should follow along with the bell curve as well. So be looking forward to seeing that in class tomorrow. Thanks for listening. Please see Schoology for more information. Have a great day.